I don't know if you noticed it, but we have officially crossed into the recursive self-improvement phase of artificial intelligence. We've been talking about this for a long time on this channel, but we're there now. And I don't think people are talking about it enough. And I'm going to show you multiple examples from which it is going to become absolutely clear that we are in the earliest of innings, but we are definitely seeing recursively self-improving agents. One agent is helping build the next version of itself. And when that happens, we are going to see an intelligence explosion. No longer are humans the bottleneck. No longer does it require human AI researchers to make that next big innovation. The only limit is how much compute we can throw at it. And trust me, there's a lot of compute out there right now. And Higgsfield is sponsoring this video, more on them later. This is the Miniax 2.7 release. And by the way, if you haven't heard of Miniax, they are a Chinese frontier AI lab putting out open source models. Very excited about this model. I believe they said they were going to open source, open weights the model within a couple weeks. So hoping to see that soon. A lot of people have been saying really good things about Miniax 2.7. That's not what I want to show you right now. What I want to point out is how they talked about how they built the model. They very much are using agents to self-improve on themselves. With human productivity already fully unleashed, the natural next step was to initiate self-evolution of both the model and the organization. M2.7 is our first model deeply participating in its own evolution. And if you think that's wild, they're not the only company saying this. OpenAI has explicitly said it, and Anthropic is very obviously doing the same thing, even if they're not saying it. Continuing on, for example, when developing M2.7, we let the model update its own memory and build dozens of complex skills in its harness to help with reinforcement learning experiments. We further let the model improve its learning process and harness based on the experiment results. This process initiates a cycle of model self-evolution. Stick around because Karpathy just released something called Auto Research, which allows even solo developers, solo researchers to do this kind of autonomous research. And not only that, I myself am doing autonomous research, and I'll show you what I'm doing in a little bit. So here's how M2.7 works. A researcher starts by discussing an experimental idea with the agent who helps with literature review, tracks a preset experiment spec, pipelines data and other artifacts, and launches experiments. They go on to talk a little bit more in detail about how that process works, but here's the key. This accelerates problem discovery and experimentation, delivering models faster. M2.7 is capable of handling 30 to 50% of the workflow. Here is the M2 iteration system. We have a human over here. The human is configuring the harness, steering the agent, and reviewing and deciding the direction of the experiments. Then here is the agent harness. We have skills, memory, guardrails, and evaluation infrastructure, evaluating how the model's performing and how updates to the model do as compared to other experiments. Then we have the agent right there. So the total loop goes: experiment is designed by human plus AI. Then the AI writes the code for the experiment, runs it, analyzes and reports on it, gives it back to the human. The human with artificial intelligence reviews and discusses it, figures out what's working, what's not working, and then they go in a loop again. It goes back to the beginning and on we go. As you can see here, they said 30 to 50% of the overall workflow is now handled by AI. It is not crazy to think it might soon be handled almost entirely by AI, with humans just kicking off an experiment direction or series of experiments and then reviewing the results at the very end. M2.7 discovered effective optimizations for the models, systematically searching for the optimal combination of sampling parameters such as temperature, frequency penalty, and presence penalty, designing more specific workflow guidelines for the model, and adding loop detection and other optimizations to the scaffold's agent loop. Ultimately, this achieved a 30% performance improvement on eternal evaluation sets. Basically, the model's good enough to improve itself now. Just so wild to think about. And you know what else is self-improving? The sponsor of today's video, Higgsfield. Higgsfield is the fastest growing Gen AI company in the world, and they have one mission: to be the most creator-friendly platform in the world. And now they are launching with Kling 3.0, one of the best video models in the world. Kling 3.0 is a next-gen AI text-to-video model that takes scripts, images, references, audio, and turns it into beautiful cinematic sequences. You get multi-shot direction, native audio, element consistency, and 15-second continuous generation. So if you're a marketer, if you're a content creator, you need to be using Kling. It can be used for everything from your marketing videos to B-roll to full AI-generated videos. Higgsfield with Kling 3.0 gives you everything you need to create incredible, visually stunning video using AI. And not only that, Higgsfield comes with a million other amazing features that you can use in your marketing pipeline. I highly recommend it. We use it at my company, and you can get Kling 3.0 inside of Higgsfield for 70% off the premium plans. I'm going to drop a link down below for that 70% off. Click through, let them know I sent you. It's super helpful. Thanks again to Higgsfield. Back to the video. Even OpenAI has said the same thing. Miniax is not the first company to do this. In fact, here is OpenAI's announcement of GPT 5.3 Codex. GPT 5.3 Codex is our first model that was instrumental in creating itself. The Codex team used early versions to debug its own training, manage its deployment, and diagnose test results and evaluations. Our team was blown away by how much Codex was able to accelerate its own development. So not only was a former model helping a new model, but the new model, early checkpoints of it, were helping to optimize later checkpoints of the same model. This was Codex 5.3. They've already come out with GPT 5.4. Imagine what that's doing. Here's an X post from Sam Altman back in October 2025, which, although only about 5 months ago, might as well be 10 years ago because so much has changed, but he called it even back then. We have set internal goals of having an automated AI research intern by September of 2026 running on hundreds of thousands of GPUs and a true automated AI researcher by March of 2028. Now, I've covered this before, and I thought the March 2028 timeline was incredibly precise, kind of in a weird way, but it definitely seems like we are way ahead of that goal. I would absolutely say we have an AI researcher intern at this point. Now, although Anthropic has been much less willing to say the words, we have AI that is self-improving, because of course they're Anthropic and Anthropic doesn't say things like that. And then also, if you look at the strategy of their company, it's very clear why it's already happening. So this was from September 29th, 2025, building agents with Claude Agent SDK. No big deal, just an article about the Agents SDK, a really cool product, by the way, but still not a major release, not a major model release, nothing like that. Over the past several months, Claude Code has become far more than a coding tool. At Anthropic, we've been using it for deep research, video creation, and note-taking, among countless other non-coding applications. In fact, it has begun to power almost all of our major agent loops. So there's a few things going on here that I want you to pay attention to. Number one, Anthropic, from the beginning, has been almost entirely focused on the coding use case for their AI models. But why? Why would they do that? Why are they so focused on coding? Well, there's a couple reasons. One, coding is where the revenue's at today. The entire engineering industry has changed overnight, and now everybody is spending billions and billions of dollars on tokens to help build software. That's great. That's the flywheel effect, because all of that revenue they can then use to go hire more people, go buy more GPUs, invest in their next model. But there's something else going on. When you have an AI agent that is incredibly good at deep research, that is incredibly good at coding, then it is building out the tools to help build the next version of itself. And there are a few dimensions in which it does that. One is just the infrastructure to actually move really quickly as an engineering organization. Everything from development tooling to infrastructure management. It is not easy to manage hundreds of thousands, millions of GPUs. So the faster these tools can be built out, then the lives of AI researchers and developers at Anthropic become easier. They ship more quickly, which, if you've been following Claude's releases in the last 2 weeks, you will know they are shipping faster than any other organization on the planet. So when you mix all of these things together, the ability to ship more code than ever, making it easier to train models, making it easier to deploy and serve models, all of these things together make it very clear that self-improvement is happening at Anthropic, whether they're going to admit it or not. Anthropic was incredibly early on this autonomous loop that they've been building. This is July 24th, 2025, in an article about how Anthropic itself uses Claude Code. Autonomous loops where Claude Code writes the code for a new feature, runs tests, and iterates continuously. They give Claude abstract problems, let it work autonomously, then review solutions before final refinements. This is happening. And Sam Altman and Jacob Pachaki, the head of research at OpenAI, and obviously Sam Altman, the CEO, have talked about it explicitly during a live stream. Let me show you that now.
We may be totally wrong. We have set goals and missed them miserably before, but with the picture we see, we think it is plausible that by September of next year, we have sort of an intern-level AI research assistant, and that by March of 2028, which I believe is almost 5 years to the month after the launch of GPT-4, we have like a legitimate AI researcher. And this is the core thrust of our research program. Our intention, our goal is by March of 2028 to have a true automated AI researcher.
All of this comes back to the now infamous situational awareness paper. Leopold Aschenbrenner wrote this after leaving OpenAI, basically saying this self-improving loop is going to happen sooner than we think. And in fact, he had a graph showing it, and I'm going to show you where we are right now. This is us, this little human right here. And right before this massive exponential explosion in progress, we are standing at it at the very bottom, but it is happening. And it's only going to speed up, and it's only going to be more exciting. And I could not be more optimistic about the future. But more specifically, this is the intelligence explosion graph. So on the x-axis, we have the timeline. On the y-axis, we have effective compute. So he is measuring how much compute is going into this. But you can kind of think of compute and self-improvement as one and the same. As we continue, we see all of a sudden, once we reach this automated Alec Radford, basically automated AI researcher, that is when we're going to see an absolute explosion of intelligence, as the chart says, intelligence explosion. And this is when superintelligence happens. And we are right here. We are right at this point, and we are seeing signs from every major frontier lab that they have models that are recursively self-improving. It still takes a lot of hand-holding from humans, but that iterative loop is shortening in time scale. And human AI researchers, human engineers are being removed from the loop little by little, and then all at once. Google is even getting in on the game. They were incredibly early on this. This is from June 16th, 2025. This is AlphaEvolve, an incredible coding model and architecture that helped these models get really good at open coding challenges and hard scientific problems. And in fact, AlphaEvolve was able to improve parts of Google's overall system-wide architecture to unlock improvements that saved them billions of dollars. In fact, it discovered faster matrix multiplication. For the first time in something like 50 years, it was able to figure out how to do matrix multiplication even faster. And again, now every single AI model after that is going to be faster. That is the definition of recursive self-improvement. And so now let's come to Andre Karpathy. If you thought it takes a frontier AI lab to do this kind of recursive self-improvement, to do this kind of autonomous AI research, you would be wrong. Andre Karpathy is obviously a very special human being, but he put together something and open sourced it that so many people have already been building on top of, including myself. This is called auto research. Let me just tell you what he says it is. The goal is to engineer your agents to make the fastest research progress indefinitely and without any of your own involvement. The agent works in an autonomous loop on a Git feature branch and accumulates Git commits to the training script as it finds better settings. Okay, let me just break down what this means. He's basically using a frontier model like Opus or GPT-5.4 to come up with experiments to train a GPT-2 level model from absolute scratch as quickly as possible. And he basically just points it in a direction, says, okay, we want to optimize for GPT-2 training. And that frontier model comes up with experiments, runs the experiments, reviews the results, and rinse and repeat. Comes up with new experiments, runs those new experiments, looks at the results, and continuously runs. And he was actually able, after a single night of running it, to have the fastest time to train one of these models on Earth. And by the way, if you want to play around with this, he open sourced it. Here it is. Karpathy/auto research on GitHub. I'll drop a link down below. And I mentioned I'm doing this as well. Well, let me show you what I've been doing. So obviously you've heard me talk about OpenClaw for what seems like forever, but it's about 8 weeks, and I've been using it like crazy. And I've been looking for ways to take parts of my workflows and run them locally on small models. I don't always want to spend all my tokens on the frontier models like Opus 4.6 and GPT-5.4. Sometimes I want to offload those to small, fine-tuned models. And by the way, I don't have an ML background, but what I do know how to do is create these autonomous research systems. It's very straightforward, actually. And so what I've built is I give my OpenClaw a goal. It, with a frontier model, comes up with an experiment direction and will run a series of experiments overnight, taking an open source model like Qwen27b, taking the training data that I already have in OpenClaw, and fine-tuning these models and then testing it against the baseline of an Opus 4.6. And it is doing that all night long. It is constantly fine-tuning. If it finds a model that outperforms Opus, I can then swap out that frontier model with my small local model. And if it doesn't work, it looks at what happens, comes up with new experiments, adjusts the fine tuning, creates new synthetic data, maybe tells me how to create better data, runs the fine tune again, maybe chooses a new model, does all of this autonomously one after another until large parts of my OpenClaw stack are now fully locally hosted. So you can see some of this here. This is some of the fine tuning experiments that I've been doing. And again, with no ML background, I'm simply working with a model to help me design these experiments and run them. And that's the key. Humans no longer have to have the expertise. You just have to be able to direct one of these models to do it for you. Do you believe me? Do you believe that we are now in that recursive self-improvement era? Because we are. We're right at the beginning of it. But the frontier labs are doing it. Individual researchers are doing it. People like me who have no ML background are doing it. And there have been 100 different projects based on Karpathy's auto research that just builds on that. It is such an exciting time. These models are going to get better. These agents are going to get better. The harnesses are going to get better. And it's going to get better faster and faster. The momentum is building. The acceleration is building. And it is such a great time to be a part of this. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one. And a special thanks to Higgsfield for sponsoring this video. I'm going to drop all of their links down below. Go check them out right now.